Okay, welcome back, and we are going to do Activity 99, Part 3. We are going to go over your analysis questions that you were supposed to do in your notebook. I really hope that you are continuing to write and complete sentences. I know you hate to write, and I know I'm not there to check on you to see if you're writing, but I still think it's really important that you are practicing that skill. It's still a really good skill to be able to write scientifically and use your English skills that you learn in ELA. Okay, so let's look at numbers 1, 3, and 4. Number one had two parts. Part A asked you to explain the skeletal changes that occurred in those whales. So when you look at M, A, B, D, and O, you are looking to see how their skeletons changed over time, the big changes that you saw. And obviously, the first thing that I noticed is that they lose their back legs. So either the hind limbs are completely lost or they are greatly reduced. We also notice that the skull changes in size and shape. The forelimbs, the front legs turn into fins, so the bones fuse together. The tail elongates as they lose their pelvis, which is their hip bones. You know, you guys, hip bones are only there to hold your legs. It creates a cup for your leg bone to pivot inside. And so if you don't have legs, you don't need a pelvis. So they lost that as they lost their back legs. And then the tail vertebrae become thicker and larger. And the enlarged neck vertebrae shrink. So remember I was talking about that long neck being able to swim in the water. You can see that the neck size has greatly reduced. And that indicates that they don't need it as much. So then part B says, okay, well, if these are the changes that occurred, what can you infer? Here's that word inference that we learned. Remember, we don't know for certain because we weren't there, but we can put these clues together and look at what we know about whales today and make an inference. So what can you infer about those changes in the habitat that might have occurred to make those skeletal changes make sense? And what you should be able to come to the conclusion is that the skeletal changes that we see going from M all the way up to O indicate that that animal probably in the beginning, when it was wolf-like, lived on land. It was a land-dwelling animal. And eventually it transitioned to an animal that lived partially in shallow water, and then eventually to animals with exclusively aquatic habitat. I mean, the fused bones into fins automatically tells you that you have an animal that wouldn't be successful on land. It's going to be better suited to life in the water. So those changes indicate that those are good explanations. Those are good inferences based on the facts that we've collected. Okay, number 3 said, hey guys, also remember, you can pause and write and change your answers. And I still really encourage you to do that because when we do graded work, you can still go back and look at your questions. Even when we take a test, because we are going to take a test at the end of the unit, you can go back and look in your notebook. I assume that you're going to, since we're not in the classroom. So take the time and fix your answers, okay? All right, so number 3, it says, in this activity you examined extinct and modern whale skeletons. How does the study of these skeletons provide evidence about how the species are related? So when we're using animals that are so old that we don't have DNA, because obviously DNA is the best evidence. That's the best one that you can have. But when you don't have DNA, we rely a lot on those skeletons. And how does that help us? So in the video, you saw him find that ear bone, or when he found the legs and the kneecap, how excited he was about that. And that's because we can use skeletons to compare similarities and differences. And that's exactly what you did in that activity. You compared how similar they are to animals we see today. So when I find a fossil, I'm looking for things that I see in modern day animals, and I see how closely related they could be. So the more they have in common, The numbers of those similarities and differences allow scientists to infer relationships among different animals or groups of organisms. The more bones you have in common with another animal that we see today, the more likely you are to be related to that animal. And if you have enough fossils, if you have enough of the blanks filled in, you can create an evolutionary tree. Those phylogenetic trees that we like so much to show who's closely related to who. Okay, so DNA is always best. Skeletons are second. It's what we like to use second. Okay, and then finally, number 4 asks you to look again at skeleton A. Skeleton A was the guy that looked like a crocodile. So he is known as ambuloceted, and he talked. Phil Gingrich talked about him in the Great Transformations video yesterday. The word ambuloceted means walking whale. So where do you think he lived? And describe how you think they lived. And so most years when we go over this, students actually don't struggle with this question too much because they look like crocodiles. And where do crocodiles live? So for number 4, we would say that ambuloceted, based on what we are seeing in his skeleton, probably lived in shallow water and or near a water habitat. And we're basing that on the fact that if you look at him, and you don't have to write the italicized words down, but just understand why we think that. So he has those very large, powerful back legs and that big pelvis, and many have resembled modern crocodiles in form and lifestyle, while we find them swimming some we think maybe they swam a little bit like an otter, using their back legs like paddles. We think they probably likely moved well, both on land and water, and can ambush their prey in shallow near shore waters using their strong jaws and teeth, because their teeth are big and their jaw, the bone structure is very similar to our very strong jawed animals that we see today. Okay, so here's what we think ambuloceted looked like. This is a picture of what he would look like. This is an actual example of an ambuloceted fossil that we have in a museum. Now, if you look at the 2 bottom pictures, these are both ambuloceted. And why do you think they look so different? Hopefully it's because you remember that fossils don't tell us what we look like on the outside. So this is one artistic interpretation, and this is the other. Both match the skeletons, but clearly they look very different. The eye placement is different, the shape of the skin on top of that snout. Look at these fins have like paddles, where this is kind of more like an arm and a hand. So the interpretation of what ambuloceted might have looked like varies from scientist to scientist, but they fit the facts. And we probably would never really know what that ambuloceted looks like because he lived in a warm climate, so you're not likely to find him trapped in ice, and he's too big to get trapped in tree sap, and he didn't live in a tar pit. So we are left finding rock casted molds of ambuloceted and try to make inferences based on those facts. Okay, so here is what I would like for you to do now. Once your notebook is ready, I want you to go into Google Classroom again and go into the classwork feed, and you are going to find a graded analysis. And that graded analysis question is going to ask you to use natural selection to explain how these changes could have occurred to the whales. How could we have got from M to A to B to D to O because of natural selection? And so we've used natural selection a few times to answer questions, and some of you, it's not always clear that you understand what natural selection means. So what I want you to do before you start that question is, number 1, I want you to read the definition for natural selection. That's super important. You have to demonstrate that you understand what that means in your answer. And number 2, I want you to look at the changes that we listed for the skeletons. So take a look at the things that we said happened, or go back and look at your chart that we made that has all of those changes in it. And then I want you to tell me how these changes would have happened because of natural selection. How would Darwin have explained it? You use natural selection to explain how the giraffe's necks changed. You have used it to explain how elephants' trunks have changed. You have used natural selection to look at how the peppered moths have changed. It's the same thing. You are now applying it, though, to the whales. So you have to use the correct words. I'm looking for things like better suited to its environment, and I'm looking for things like more likely to survive and reproduce. And you're going to want to use the word mutation, and you're going to want to put all of that in there to get a 10. I will attach the rubric so that you have it. It's the same rubric we've used all year. It's going to be a 10-point question, and I expect you to have it done for Monday. And I want you to ask me questions if you're stuck or you're confused. Go back. You can reference the notebook pages or other videos or the things that I've showed you along the way. But please, if you're struggling or you're not sure where to start, send me a message so that I can help you. Okay? All right, we are almost done with evolution. We have 2 more activities, and then we will be done. So we're almost there, you guys. Hang in there. Good luck on your graded analysis. I know you're going to do great, and I will talk to you soon. Thanks, guys.